Okay. I'm going to try to figure out what I meant by test const expert cast of a string. What does that even mean? Let's look into here. String. That's the only thing about strings in const expert is that they're non-zero. So really, yeah, this is for like evaluates to true, but I know that that works. I mean, I guess I can just do well, it certainly says hello. And I can check. So when I evaluate a static if, well, let's see what the condition type is. Shut up about the breakpoints. I don't. All right, where was that previous one? Here. All right. Is this the right one? Expression, file name. Release, build. That's why we couldn't set the breakpoints. Build. What are you doing? It's just hanging now. It's just hanging. It's simply not working. How about if we do a Q&A while I wait for Visual Studio to stop being a butt? Canceling diagnostic session. It's going to do this every time till I restart it, I think. This has happened to me before. All right, expression file name, preload, not correct. Okay, foo is correct. It's a literal. Okay. And it does evaluate to true. So that's the only const expert related thing about strings, unless someone can think of something else. So, well, I guess I can also check that this evaluates to false, right? Which it does, because it didn't print it. Look in my SVN log to see when I added it and what else I was working on. Maybe, but I don't care that much right now about stuff like this. Like, if this is actually important, it'll come up again later. My goal today is to just blast through as many real issues as I can determine. So, and also, you know, I think I even wrote that before we had const expers or something. And I just did tons of string casting testing yesterday in yesterday's stream. So I think I'm going to declare that one done. Okay. Let's do this. Let's pick out the things here that are obviously errors. So this one is obviously an error. We'll move that to the top. This is an error. We'll move that to the top. That's a hairy one. Let's not quite do that one yet. It might be hairy. This breaks that. It's not. All right. So rough priority order here. Incomplete, make sure these work. So we're casting from a relative pointer, or we're casting from, no, we're casting from an integer to a pointer here. That's not relative pointer, it's just an integer. Why is this flagged relative pointer casting? And why does it say these? I think some code was pasted and stuff. Let me do that. Let's do a blame on that, since we're talking about source history. So where's blame? See how long this takes. All right. Okay, make sure these work. This is revision 3421. All right. How do I view this at a particular revision? Do I do it? Can I just do it from here? I just want to view version 3421. That's how do I do it? Let's try repo browser. Revision 3421. Yeah, this was totally different. So this, oh wait, no, there's two of them. Wait, we're searching through all the files in Visual Studio. Okay, wait, make sure these work. Okay, that's line 1139 of this file. Yeah, so this comment used to be in front of totally different code, right? And we broke that up. So basically we're just saying make sure that these pointer casts work. Okay. So we do a number to number cast. I believe if it's actually a cast from a relative pointer to a relative pointer, yeah, then we'll have this, right? So, and this is already tested for in our test cases, right? So here we're like doing all this relative pointer encode decode kind of stuff. Right, remember I called some of these same routines yesterday about emit, convert full to relative pointer and all that. So I'm pretty sure that this has been done and tested and all this stuff. The one thing that I think maybe we do is just test converting from a small integer to a big pointer, right? Since that comment was there, let me close Photoshop. No reason to have Photoshop open. All right. So we're just going to go back here. And we're going to say x, y, s16 equals 4003. X is y, print x is whatever. Oh, colon equals FA3. Is that hex for 4003? I think it is. Let's make this a hex number, 4003. Yeah. So it's working. It's giving me a pointer. This should give me maybe an overflow. Yeah. Numeric constant too big for type. But it won't be too big if I do that. That works. Oh, numeric constant too big for type. 1, 2, 3, 4. Oh, it's 9 digits. All right. There we go. So that's all working. So fine. I did make sure they work. Okay. Okay, we don't get a proper body dependency on guy. I hope that's fixed due to some other things. I believe this should be fixed by some very heavy reworking I did about a month or two ago, but oh wait, that's just gone now. Yep, that code is just completely gone. Let me see if I have do I have any equivalent? Guy equals dot dot dot. Nope. Nope. All right. Well, column that fixed. All right, this one is scary, but let's see what happens. Copy string. I'm scared. Yep. I do not like problems like this. Okay. Well, I mean, we have to fix this because this is not acceptable. This is not acceptable compiler behavior. I'm trying to remember, last time I looked into this, exactly what the issue is. I actually don't know. I mean, let's see. Let's see. And we're looking for exporting something that has not yet been inferred. We're looking for that. Oh, this may be so painful. Oh. What? What? Wait, what was I compiling? Same thing. Okay, we have a lambda that's not inside a scope. That's a problem before we talk about anything else. Like the constants block for a lambda should always be within a scope. This isn't copier. Let me guess, it just hasn't been what? It has been inferred. It's alloc, all right. Its header is in the size pipe. Its body is in the infer pipe, but that's fine, I think. Maybe not. Maybe not. Does alloc live in basic or preload? I think it lives in basic. Yeah, it lives in basic. And it just says, hey, we're calling context.allocator with some arguments. Ain't no thing. All right, well, that is certainly weird. So let's just trace where this guy gets constructed and figure out why he is not parented. To the global scope, or at least to file scope or somewhere. Let's quick lambda, let's modify, it's a run directive, it's an assert directive. We just corrected those yesterday. Parse lambda. This should get set here. Let's oh God. Okay, this is a weird hack that we did. Okay, we shouldn't be copying here. That is for sure. I hate this edit and continues. What did you just do? Ugh, Visual Studio. All right. That might be simple enough. I don't know. I suspect not, but let's see. Oh. Okay, so the reason we have this copy here, let me talk about that. Remember earlier in this stream where we're like, hey, if we've got a literal, we can tweak the number flags and whatever. Well, in this case, we're setting the inferred type on something. And that something may not be the original expression. Like it may be a constant that came through some identifier and so forth, right? You know, this is going to have to change later. See, like if you have an identifier foo and it's defined to be a constant 3, we evaluate straight to the 3 here. And that's not going to be good. Well, because that's going to mess up the syntax tree that people see. No, because we put it on substitution. That's good. Okay. We don't change the expression. We put it on the substitution. So the thing is, we're changing the type of the thing to match what the argument's declared type is. So if it's a constant 3, but we say it's a U64 on the parameter, then we want to make sure it's a 3 that's tagged as a U64 3, right? So this does that, and the problem is if we got the 3 from somewhere else, if we set the type, then we end up stomping on the node, right? Now the problem here is what happens. We need to do this because in some cases the parameter type is different from the constant type. Which could conceivably happen for procedure if there was some way, like if we were just casting a procedure to void or something. Dude, I don't know. Okay, we're going to put in a safety valve for that case. We'll do an internal compiler error for now. And we'll put a note in that internal compiler error that there might be some way that you could legitimately produce this. Okay, so here's what we're going to do. If it expression inferred type, or if x inferred type is not equal to I want to do something. Yeah. We're going to call check the types match on the inferred type of the declaration and check that that matches x. Okay. Who even knows what that's going to do? Hey, it compiled it. It ran it. That's awesome. So the good thing about this is now, when you say copy string, you can pass the allocator as an argument. And it'll just use it. Of course, it won't just use it yet, but alloc with of course, we don't pass allocator data in here, so no long term, I think we want that to be. Maybe it's like a closure pointer for the frickin' Lambda, I don't know. Okay. Type mismatch. Oh, because alloc isn't an allocator. Never mind. That's just, yeah. Maybe I should pass an allocator. Oh, well, we haven't done the release compiler yet. Yeah. Okay. Does that work? Okay. So here we're saying this is going to be known at compile time, so it's not going to cost us anything, right? So we're going to say if allocator, we do something there, else we do something here. I don't know, man. Whoops. And that doesn't even trip the same bug anymore. It's okay though, we fixed the bug. All right, so that runs. That runs. Okay. Yeah, sorry, I'm too slow in real life. Too slow in real life. Bug 43. All right. We just finished what we were doing. How many lines is to-do.txt down to? 335. It's getting smaller. Some of these are definitely just ideas. Let me make an ideas text. Because to-do.txt I want to be I think this is fixed. That's an idea. That's an idea. That's an idea. That's an idea. We already do that. these are definitely ideas. That I already have elsewhere in this file. This is a to-do that's not about the compiler, but I should do it anyway. I'm pretty sure you already can do this, but we'll put that up at the top. That's a bug. That's an idea, I think. That's an idea. I should definitely test that this is fixed sooner than later. That's been done. This is an idea. I already sort of tried it, and I need to think a lot more about it. That's an idea. That's an idea. That's an idea. I think that, well, we just showed that that must not exist anymore, that comment. Pointer to pointer. Whoa, really? What? Oh boy. Okay. That needs to happen soon. Could maybe even do that tonight. That's an idea. That's an idea. That's an idea. These are ideas. Okay. So that I've done a pass through the file. So there's 257 lines of actual to-dos. Yeah, I might have meant that pointer is never null, by never zero, but I'm not sure. Bug 43, yay, we love bugs. Let's see what this says. Oh boy. The context is not ready and we're trying to use it. That's not fun. So we're trying to run and add context too early. For some reason. It's what happens when your language offers a lot of features. Sometimes there's bugs in those features. Could have just not had user expandable context. Wait, what? Bug 43. Oh, I gotta run into bug. Gotta run into bug. All right. So, why are we doing this too early? We're inferring types, context or push. Ha ha ha. Okay. Wait, what's the assert exactly? Okay, actually, the problem is we're trying to sleep on this. We're trying to sleep on this. It's past the point where we should be sleeping, but we haven't created the context. It's like we hit it in the split second thing. So we'll say the following. If all right, see what happens there. All right, well, I think we fixed that bug. Let's look to make sure there isn't another bug. Well, yeah, I mean, there is no non-existent right now being defined by this program. So that is correct behavior. I guess I should test things before I check this in. I doubt that this had adverse effects, but the reason we have tests is so we can run the tests. I should bind the test running to function keys, so I don't have to search for it in my history. All right. That was a quick work of bug 43. Abner thinks he can just file bugs on me and slow me down, but sometimes I actually fix them. Take that, man. If Abner's still watching, my wish list for, it's a very simple wish. As we add more and more tests, it's more and more annoying to scroll back to make sure that they all succeeded. So it would be good to just add all of these up and just put a final total at the bottom. That's always at the bottom, because your expectation is that they all succeeded, or in this case, I'm ignoring just one. So I know if one has failed that it's okay. But just to see at the bottom, like n out of n with whatever percent would be great. Yeah, all right. Hopefully no bugs will come up, but we all know about bugs. We all know that bugs can happen. I do not claim to be the perfect software author who never creates bugs. Okay, this is kind of serious. And in fact, we probably, I'm confused about this. Which bug was it that had the relative pointer? It was this one. It was bug 42. So I guess we compare in here, but we don't ever say, for example, B equals C. So I think we need this kind of thing in the test suite. So I believe if I say this, it'll currently give me a compiler error. Whoops. Wrong thing. Well, it didn't even do that. Wow, I wonder if it's like infinite looping, making cats or something. Okay, that definitely needs to go in the tests. But you don't need to file a bug on it because I'm fixing it right now. Let's see what the hell is happening. Okay. Oh, that's an LLVM crash. There's one of those that Josh was going to be looking into. So, of course, I don't know why. Yeah. Let's run it with -x64. That works. All right. That didn't produce an internal compiler error, which is interesting. Those are different types, right? B is a string S16 and C is a string X32. Oh, it works for strings. Right. So let's just make sure that that works. But I need to check it for pointers and not strings, and I believe it won't work for pointers. Yeah. So it works for strings because that's what we did yesterday, but it won't work for pointers. But yeah, this does need to go into the test. And we can file that on Josh because that breaks the LLVM backend, but not the x64 backend. I'll make a note to do that if Abner's not listening. Okay. So now if I go down here, let's just comment out this stuff anyway, because it's getting kind of long-winded. I'm going to say A is a pointer to U8 buffer.data. B is a pointer 32 we print A and B. No L value expression for relative pointer encoding. That's weird. I didn't expect this to break yet. Does it break if I do this? I mean, it probably does because it's the same thing. Well, we got some things to debug about relative pointers. Relative pointers. Okay. Emit code for declaration eval for ident. Okay, we're assigning to an identifier, right? We're saying B equals whatever, which means we're trying to put this value on the stack. Right, because up here, so we want to get the L value and pass that to full to relative pointer. Okay, so this stuff is stuff that I changed just the other day on a stream, and apparently I broke something that we weren't testing for, is what happened. Okay, so we get here. This declaration does not have a stack allocation? Right, because it's got a value register. Okay. Oh boy. So the deal is, we did not give this declaration stack space, but we need to do that for relative pointer encoding for some reason. But maybe that's the problem. So the problem is this convert full to relative pointer expects to write the relative pointer directly into memory, which frankly is too strict. Because as an intermediate result, wait, what? This doesn't even use that. Oh. Oh, right. Okay. Relative pointers always need to have stack space because they're encoded relative to their memory location, right? And if you don't have a memory location, then you can't be a relative pointer. That's just how that works. So in bytecode builder, there's a place where we say, for example, if something's address gets taken or whatever, these are the conditions under which we do a stack allocation. And we need to add if it's a relative pointer. So let's go back a second. Well, we'll just say, or if we only lived in a register, we would have no address. All right. Hey. There we go. It's a relative pointer, and it encodes to the same thing. So that's great. Now, let's go back to this version, which hopefully still works. No. No L value expression for relative pointer encoding. That's probably trivial, but because there's really no real difference between that and the thing that I just deleted, right? This is just the same thing broken into 2 lines instead of on 1 line. So it's like whatever's handling this case. Like that. It gave me a temp file, and I put the breakpoint in the temp file. Visual Studio, never change. Never change. All right. So the caller here did not supply the L value expression. And it's on the cast. That makes it a little more annoying, because where does the cast come from? Wherever the cast was created, I pretty much know where it was created, but for the sake of thoroughness, we'll go find it. Oops. Okay. All right, so we're making an implicit cast. Let's go back there. We need L-value expression. We need relative pointer L-value expression. That usually happens in operator equals. Yeah. So like what happens is in operator equals, after we do the type check, we check if a cast was generated for a relative pointer type. Yep. So that we just need to point that at the declaration itself in this other case. So after this, if decal expression, what line was that, 2400? 26 something, 2610. Wait, what? Yeah. So we look at the cast and this is internal compiler error, but we need to test this to make sure that works before we can call ourselves done. Relative pointer L-value expression. Whoops. Wait, have I been typing in here? No. Why have I been typing into Visual Studio? What kind of dumb person am I? All right, whatever. Do this again. All right. So we get a cast. Then we say, you know, we can forget all this. Forget all this. If decal expression or value, if why am I typing in Visual Studio? All right. Boom, boom. Then the whole point I'm trying to get to is this. And I hope that that's right. Expression is not an L value. Now we got to take this off because it's slow. Okay. But we happens when we say relative into okay. If it's a declaration, then emit code for declaration eval. Of value type and print site. All right, so that works. Now, finally. Let's check that in, but then there was that extra thing that I wanted to test. Okay, so that's working. All right, that's good. So, that's weird that I managed to do that whole relative pointer demo way back and never run into that problem. But that's what we're doing here, is we're stress testing things further than they have been before. Okay, now, I haven't even gotten to the other thing, right? So we want this, and we want to be able to say like C equals B, first of all. And then we also want this, but first let's do C equals B. I don't think that's going to work, because I think that's going to trigger the whole thing that I started to debug when I then had to derail and do the other thing. Because I got it, whoops, that's not what I wanted. That's the wrong program. Yeah, we do not yet handle pointer-to-pointer relative casts. You know, honestly, I think we just go to full-size pointer and then go to relative pointer. And we let the optimizer take care of it. Because you can't just change the size of the number, right? You also have to do the math for offsets. So this is what I was trying to get to in the first place. So where is it? Relative casts. All right. So int full pointer register convert from all right. Because eventually, if I try to get fancy and just handle this in a tricky way, we'll get screwy later. Like we might have options about what the relative pointer encoding is that could be different between two pointer types. Or like maybe you provide a procedure to decode the pointer, like all this stuff. So we want this to just work for everything. So we're going to do the following. Full pointer register. So we loaded the relative pointer. And then we want to do this. Full pointer. Okay, so yeah. All right. Maybe that works. No, it doesn't work. I messed something up. Because C should point at the same thing that B does, so the decoded address should be the same. Should be the same. Load relative pointer, source relative pointer type, source memory pointer register. Not our value register. What? Wait. Right, this is just to get the address. This already has the value in it. Well, you know, I can do a trick here. Yeah, it's called debug print register. So I can do this trick. I can make sure that this is correct. I can say print full pointer register. It's a good thing to have in your bytecode. Now that's only going to work in bytecode, but I can go to the repro and say run main. Okay, so R15 is 3CO4150, which is, by the way, okay, wait, that all worked. What? It works in bytecode and not in non-byte code. Why would that be? This may be just a different bug. No, I mean, wait, what? Oh, that's in bytecode, right? It doesn't work. Oh, wait. It's an LLVM backend bug. Because it works in bytecode and it works in x64. Oh, assertion failed anyway. Well, I should fix this. So equality between relative pointers. Right, remember the thing that I did about equality between strings where we cast them up to full strings? That needs to happen with relative pointers as well. I'm amazed I did that demo and didn't run into this stuff. What was that called? Oh, emit code for conversion to full-size string. Is this in, where is this code? Okay, really the right thing to do is first warm up some tea and get some sugar. So I'm going to take a 2-minute break while I do that. And then I'm going to go into the type checking. So the thing is, the thing I was saying yesterday about when you do operator equal on relative strings, that they need to be casted up to big string, that needs to happen here as well. And the thing is, I don't think this is the right place to put it, actually. Okay, and this isn't right anyway. Okay, there's problems. There's problems. Taking a few minute break. Alrighty. I need to question why I did it this way yesterday. First of all, for strings, I got to write down all the things I need to deal with. So string equality, rel pointer equality, rel pointer subtraction. Those all things need to work. And then, of course, the whole C2 equals C needs to work. Okay. No, this is right. Okay, this has to be here because we can always explicitly cast a string. That's fine. Okay. So the policy that I'm thinking about is that if it's a relative pointer, we cast up to full pointer at this location. We just insert the casts so that string comparisons work. In fact, for any binary operation, well, we don't really do pointer and multiply or anything. We just do pointer add and pointer subtract. Pointer add already works if it's just an integer. So we just need to handle pointer subtract and equality, which is what we're doing right here. What is it called? Switchable expression pointer, but instead are setting the substitution this will break because the checks. Okay, so that's going to break in the future. That's not even, I'm going slow right now because there's like 5 different things I'm thinking about at once. So if we're doing a test for equality or inequality, we want to cast these both up to relative pointers. Oops. Okay. We are casting these to void, but then we are all right. No, that's not what I wanted. All right. Well, the assertion failed still. Let's make sure that casting these to void works. Am I even compiling yet? So VC, the pointer to void. So we want to make sure that works, casting straight up. So VC is the right address. VC2 so VC and VC2 are working, but the equality test is not working. So the line 94 assert is working, line 95 is not. So the thing that I just did isn't doing anything. Oh, it's because it didn't compile correctly. No wonder. Because I didn't add that, because it's C++ and you have to do everything twice. You have to do everything twice. Because C++ values your time and energy. All right, well, okay, well that's not quite an improvement. The hell are we? Oh, I made a cycle probably out of the substitution. Right. Well, cast expression. Wait, what? Oh. So the cast's expression substitution is itself? How did that happen? Oh, I know how that happened. All right, I can't do it with the substitution. All right. Got to do it twice because C++ values your time. Well, that's because it was the debug compiler, not the release compiler. All right, that's that LLVM problem that we're ignoring for now because it's someone else's bug to handle. Hey, it worked. The assert did not go off. So I can get rid of my debug print. Okay, we're getting somewhere. Okay, so I wanted to put a test in here. Wait, we did do this test of B equals C. We did that earlier today. So that's fine. Let's just make sure all that still works. And it works in the executable and not just in the bytecode. No assert has fired. That's great. Now, we've got to do this last scary thing, which I hope is not actually scary. We're going to say P1, P2, calling C2, print P1 is hey, okay. No. Okay, these are copying the value. Okay, wait. Yeah, this is no good. This is no good. What if we go P1 is a pointer tilde S16 U8 and so is P2. P1 equals C2, P2 equals C2. No, this is all wrong. Okay, the problem now is, okay, if I change the type of these pointers, then it'll be correct. Right? Now they're pointing at the right address because that pointer-to-pointer cast was invoked. The problem is the problem is that if we compare two pointers, if we do anything with two relative pointers, we have to generate a cast in order to prompt that translation. Otherwise, it won't happen. Yeah, T helps you solve problems, man. It's a magical liquid. Magical liquid. Okay. So, in typer.cpp, hey, now the address is correct. See, the relative values are different now, but the addresses are correct. That's what we want, is for the address to stay the same the whole time. And we need another string test. We need to say D equals we need to say test that two strings. After D equals C, D is blah, blah, blah. Blah, blah, blah. After D equals C, D is hello. All right. So, that said, this should automatically work. Well, let's see. P3 and P4, we'll do this, because a declaration is a slightly different case, apparently. And then P5, P6. All of these need to say the same thing. Now I'm confused. Oh, because I'm printing out the wrong things. Those numbers didn't make sense to me, and I'm like, there shouldn't, yeah. Okay, these are incorrect. Yes, thank you. These are incorrect, but we've made progress. So I'm going to check in progress toward relative pointer correctness. Okay. So the declarations, we once again have the situation where declarations are not doing the same things that assignments are doing. They're not invoking that cast, right? So what's happening is they're being set equal to C2, but it's just copying the integer value r minus 106 instead of casting it up and back down. Okay, wait. This is what I wanted. Okay, here, okay. Wait. We just said that we modified check that types match to insert that cast in all cases. So that cast should be getting inserted here. So I need to actually debug this and see what's going on. Line 110. Oh. Let's work around that LVM backend problem. Okay. Oh, this is only happens if there's a type inst. Oh, that explains a lot. When we use type inference, like here, there's no type instantiation. Okay, well, if it's not a constant and oh boy. This really should go in here. Okay, so my brain is running out of steam again. I'm tired from all my traveling. So we're checking that the types match. That's the second step. The first step is ensure that didn't work. because we built the debug compiler, not the release compiler. Let's try the debug compiler. Control compiler error, no L value expression for relative pointer encoding, because we didn't do our frickin' thing. Oh boy. Yay. Awesome. Hey, Abner, if you haven't seen this, because you were off making the test suite better, bug 42, which I'm about to check in a better version of, works in x64, but not in LLVM. It's got another one of these type errors, which may or may not be the same one that we were seeing before. So it's just like, hey, maybe it's another repro or whatnot. So bug 42 now does a ton more testing on relative pointers, because I found a ton of problems with relative pointers. So we probably should work this into a more official test case as well. But I'm going to check this in while I'm ahead, because damn, there were a lot of, oh no, oh, we crashed on Sokoban. Okay, I did something dumb. I can't check this in yet. Can't check it in yet. Let's get rid of our weird breakpoints. Oh, we don't. Oh, we don't have a type. Wait, what? The hell is this? Undo line 145. Oh, it's an iterator, right? It's called it. And we do weird things with iterators. Dude, I think an iterator that's a relative pointer. Oh my God, that's going to be so ugly. Hey, Abner, if you're watching, make a test where there's an array full of relative pointers, and then we run an iterator over that array and watch it explode because it's not doing the right thing. Yeah, well, I'm sure still finding a lot of bugs right now. Mostly, though, in the more recent features, right? So relative pointers, I just fixed like 5 bugs in relative pointers. But that's one of the newer features, and it hasn't had that much testing. So, and it doesn't get used really in Sokoban at all right now because it's such a new feature. So it's not that surprising that it had a lot of bugs. I do think it's encouraging that the bugs that you're finding and checking in are on relatively rare. So like bug 43 was context add bug, which is a new feature and also a rarely used feature. So I think it is getting better. I think it is getting better. Okay, what am I doing? I'm tired right now, so my brain just dropped. What? Oh, I'm fixing this bug is what I'm doing. Okay. Iterators. Stuff does not kick in until later when gets set. Okay, wait. Yeah. Gets set. Except it does not kick in later because we don't do it. So my theory is that our relative pointer iterator currently will break. I mean, probably, maybe we want to force a relative pointer iterator. Like, we should just do a special thing where it becomes an absolute pointer anyway, because you don't, like, you want to be able to iterate over an array of relative pointers to things on the heap that are near themselves. Yeah. Oh, and you know what? I never tested pointer subtract. Let me write that in bigger letters so I don't forget. Pointer subtract. Okay. Okay. That may not be our only problem. I mean, history would say it's skillful to presume we have other problems, but maybe not. Maybe not. Maybe we could actually compile Sokoban and it runs. Okay, so let's test the repro with the release build. It's not terminating for some reason. Okay. Oh wait, it's only getting, right, it's crashing. Because it's only getting to the first. No, it's not. What? Okay, hold on. Let's just check. Let's make sure Sokoban runs. If Sokoban runs and the tests run, then I can check it in to at least have a checkpoint, and then we'll figure out what's going on there. Okay. So that's good. So, more progress toward eliminating relative pointer bugs. So I'll update to get the fancy new test. Boom. Yes, and now we have a summary. 15 out of 16 files were successful. So I guess it counts files and not individual functions, but that's fine. Right, and it gives me the one that failed. So that's good. I don't have to scroll up anymore to see my constant failure due to my laziness right here every single day. I'll fix it soon. I'll fix it soon. It's just, this is not that important compared to what I've been fixing for the past hour or two. What do I think about Perforce? I have not ever used Perforce, so I can't tell you anything about it. I have, however, spilled tea on myself, so I can tell you all about spilling tea on yourself. I can't tell you anything about Perforce, though. No one can tell you what it's like to spill tea on yourself. You have to see it for yourself. All right. Okay, so did I just check in? I think, yes, I just checked in and updated. So the next maneuver is to figure out why we're crashing on bug42 repro. Which we weren't crashing before. Oh, that's LLVM again, so let's x64 it. We're not, are we only crashing in release build? Oh no, I think okay, what happened is just we're hitting that same LLVM bug. We're fine, right? So if I run with the x64 backend, we work. There's an LLVM backend bug that has been assigned to someone now. So my work here is done. That's good, because I thought I had a scary thing. Spill tea with sugar on a microswitch keyboard. Yep. Especially if there's a lot of sugar. Lenovo lunch. All right. That's a good one. That's a good one. All right. I've still got tea all over my desk. So I'm about ready to take a brain break and maybe do questions, both on topic and off topic. But before we do that, there is one more thing that needs to happen. And that is the following. We need to do pointer subtraction. I'm going to say f is buffer2.data, delta is f minus c, f minus f. So this should be like 100, or maybe there'll be some alignment there, I don't know. And this should be 0. Something tells me it's not going to work though. 80. Yeah, that's wrong. So the reason that's coming out as 80 is that C is minus 204 in relative, and F, well, let's print F. F is minus 124, right? So the difference between those is integer 80, but it should be 100, or let's see. Let's say correct So correct delta is buffer 2.data minus buffer.data. Right, so correct delta, correct non-zero delta is 100. So my job is to fix pointer subtraction so that this comes out at 100. But once again, I'm confused. Because check that types match should be generating the casts properly. There's 3 people working on the compiler right now. Three peoples. I'm not working on it all the time because I'm working on all this other stuff too, but I work more than full time, so it probably balances out. What I am doing is that there's a feature called relative pointers, which are smaller than regular pointers, and they're relative to their own memory location. Because they're relative to their own memory location, when you do operations on them, you need to like translate them into global pointers, and that's not happening all the time correctly. Because it's not happening all the time, we're getting wrong answers to some things. For example, we just subtracted 2 pointers. We're supposed to get 100, and we don't get 100, we get 80. So the reason we're getting 80 is because we're not converting them to global pointers correctly. And what I was just saying was check for pointer math. If pointer math I don't know why I need to do that. But it fixes it. I think it's because I don't do check that types match for some reason. No, that didn't. Okay, this is confusing me. All right. I need to trace through that. Okay, so we're going to step into check that types match, which is massive. And checks all kind of cases. Okay, they're pointers. Okay, this is wrong. This is redundantly this is, I'm not sure this is right. All right. So our expression was null to begin with. Oh, geez. This whole relative pointer L value situation is a problem. It is problematic, as social justice people say, except not. The positionality is problematic. The hell? There it is. Edit it. Wait, what? That's not it. Why does it have a 0 in front? Is that going to make it octal? Why did it paste a 0? Oh my god. All right. Was that left over from the old constant? Like, all right. All right. Okay, so we're making a cast. We're making an implicit cast. Boy, this code path has never been tested before, that's for sure. That's for sure. Like, I just don't even... There's definitely going to be cases in which this stuff breaks. What is... I hate this program so much. All right. I'm digging it a whole big can of worms here. Now, I'm not sure that I like what I'm attempting to do here. But it ran, I guess. Yeah. See, this thing doesn't like that it's I'm not sure what to do here. It's like, in the extreme case, I kind of need to have an L value every time I do type checking between a thing that may be a relative pointer. No, you know what? Okay, this is goofy. This is goofy. Because all this worked fine. Like I said, this stuff is never tested, and I don't think it's right anyway. Because we don't want to generate a cast to a relative pointer anyway. We want to okay. Actually, whoa, I put this in the wrong place. This is if we're not pointer math. There we go. This was the right place. And I'm going to have to factor this because I just realized I'm maybe not checking this in some of these other cases, which means I would erroneously modify user inserted casts that have nothing to do with that. Dude, I'm so far down this rabbit hole. Okay, yeah, it's not an L value. I kind of want to be done with this topic. Expression is not an L value. It's a cast. Okay, that's no good. It's pointing at itself, so I goofed there. Because I'm getting tired, I goofed. I goofed. Because check that types match is going to modify the node on the right. It didn't work. Maybe if I run it a lot of times, it'll work. It's not working. All that I'm going to put this down for a later bug because this worked. I believe the check that types match above should also have solved the problem, but it doesn't. I think we need some more thorough tests that will perhaps break to pointers in some clear ways that we can fix. Okay, so we're just back to this working. That's fine. This is a perfectly good solution. It's just that I thought that the other thing would have worked as well, and it didn't. Casey wants to PUBG. Maybe a little later. I am maybe in 20 minutes I am trying to finish this programming problem live on stream. Mismatching relative pointer types. What are you talking about? That should not be a relative pointer at all. Oh! Because, remember this? This used to fire if the following. So we need to replace that. I'm so glad I thought of that because I could have taken like an hour trying to debug that. That is some next level debugging that you just get by instinct once you've been doing this forever. Oh my God. All right, that could have taken, like if I could have been slowly plodding through that for a long ass time. But if you make enough mistakes that are similar to that, then you're good. All right, this is good. We only still fail that one same test. And this is all still working. So this has all been fixed. Pointer subtraction works, so I'm crossing that off. And I'm going to go into to-do. We did pointer-to-pointer relative casts, in theory. Down to 255 lines. And I'm going to put this first for next time because, yeah. Because that's done. So, thanks everybody for coming by. I may stream again later tonight, you never know. Compiler size, 41317. So we're up about 90 lines for the day, which is not great, but we fixed a lot of problems in that 90 lines. Yeah. All right, thanks everyone for coming by, and if I can't sleep again tonight, which is quite possible because I still just recently got back from this trip, I may do yet another stream. I don't think I'm going to stream PUBG this time, but maybe. We'll see. Good night, everyone.